Hello and welcome to RESO's Remote Digital Tech Summit. I'll be doing a session on standards and how they simplify data sharing between MLSs and brokers. Before I get started, like many people, I'm working from home right now and there's a lot of noise sometimes. I've tried to keep it to a minimum, but if you do see a little baby run in the background, just ignore it. First of all, let me introduce myself. I'm Frank Major. I'm Chief Technology Officer with Bright MLS. Bright is a large MLS in the Mid-Atlantic region. I joined Bright about a year and a half ago to lead both the product and IT teams. Before joining Bright, I primarily worked at large financial institutions like USA and Capital One, or e-commerce providers like Amify, who did work in the Amazon marketplace. In both situations, I primarily work with large enterprise systems and big data, so that's kind of the background I bring for this discussion. One area that I think we're all aware of is the true intrinsic value of data. Data allows us to make more informed decisions. Data allows us to solve problems. It helps us to understand the performance of our solution. It also helps us to understand how we can drive out process improvements across the organization. So the value of data to organization is incredible. Many organizations, one of the most important assets the organization has. The lack of data, as this quote kind of here, it forces folks to really rely on their gut feel or experiences, which are great in many cases, but in an ever-changing marketplace, having access to data is how we make good decisions. Before I get into kind of how data standards help to simplify the process of sharing data, I kind of want to walk a little bit through kind of the data journey we've all gone through over the last 40 years. Prior to like 1980, the data model a lot of people saw were these large data centers where both the data and the compute were co-located. This was realized really a lot in mainframes. And with the mainframes, both your storage of data and your compute of data were co-located. And then you would access that through some kind of dumb terminal, things of that nature. 80s through the 90s, what we saw was kind of a beginning of a distribution of data and compute, where we still had the large data centers for large to mid-sized institutions, but the data and compute were starting to distribute a little bit. And primarily that was driven by the advent of the personal computer in both the professional and personal lives of individuals, where they could do some of the compute on localized systems, be the storage on your personal computer and the compute power of your personal computer. But still, a lot of data was housed in these large data centers. As we transitioned into 2000, kind of the cloud era, we really saw, still these large data centers out there, but more and more individuals pushing their data to the cloud, which allows to really separate both the storage of the data in the cloud and the compute of the data on a device or in the cloud or on a PC or whatever. And really with the growth of the Internet of Things, we've seen more and more data stored in the cloud in a more real-time fashion. So as we transition to the separation of data and compute, it really gave some neat capabilities we can leverage, and we'll discuss some of those as part of the session. As we talked about data, let me just give you a couple of data facts. These are all based on IDC. IDC came up with this concept of a term called the global data sphere, which is an interesting term, but basically it's all the data aggregated across that's captured, delivered, created, and replicated on the planet for a given year. And based off of IDC's estimate, in about 2010, we had about 1 zettabyte worth of data. And basically, a zettabyte is a trillion gigabytes of data, so a large sum of data. But around 9 or 10 years after that, so 2019, IDC estimates the amount of data in the global data sphere about 40 zettabytes. There again, in not even 10 years, we went from 1 zettabyte to 40 zettabytes. In 2025, IDC estimates there will be over 175 zettabytes worth of data out in the global data sphere. So we really see this growth of data, and the ability to collect data and store data is really around that. And the cloud is a big proponent of that ability to store data in an efficient manner, or I should say efficient manner, but at inexpensive cost. On top of that, there's more and more capability to get real-time data pushed out to you. With the Internet of Things, there's all these devices that are collecting data and pushing data to data stores in real time, but also the ability to distribute data out to these devices in real time really means that we can get real-time data to everyone's fingertip pretty quickly nowadays. One way that Bright and many organizations are looking at leveraging this is this concept of a data as a service, which is basically our primary goal there is to allow data consumers, our brokers, our agents, the ability to obtain data on demand. So when they need it, not when we think they need it. So they can obtain the data on demand through these data services. And why this is really a model we think is beneficial and been around for obviously multiple years is since we now have the capability to store data separate from the processing data, we can collect data kind of as we see it. And we don't even have to have a purposeful need for that data collection at this point because the storage of data is so inexpensive. How Bright has achieved that is we're really leveraging cloud technologies. We're leveraging cloud technologies to store the data. We're leveraging cloud technologies to compute on the data. And the most important piece in some ways, we're leveraging cloud technology to distribute the data out to our data consumers. And that distribution of data is really where data standard stands out. It allows us and our data consumers to get on the same page quickly and to make sure we understand kind of the syntax both and the semantics of the data we're exchanging with them. So if we look at data standards, I think they kind of fall into two areas that really add a lot of value, at least for Bright. First is the alignment. It gives us a common language between us and the data consumer or how we want to exchange data. So when the MLS wants to provide data to the brokers, having that common language or vocabulary is really important. It simplifies onboarding of new data customers. So the fact that we all have a common language when we go out to new brokers and new entities, we don't have to have a large debate about what are the attributes, what are the meaning of those. There's this common language that we both understand and allows us to drive forward at a more rapid pace. It also allows us to provide a more of a self-service capability for our data consumers. By that, what I mean is we can lay out a data catalog with a defined set of terms and attributes in it. They can consume that catalog knowing that they're using the same, again, vocabulary that we do. So when we talk about values, we understand between the two of us or multiple of us what's in that catalog. And with that catalog, they can choose what data they want to perceive from us in this self-service manner, and they don't always have to. So we can publish a catalog. It can be based off a well-defined standard like RESO, and they can consume that catalog, making it simple for them. So that's kind of the alignment aspect of it. There's also this adaptability aspect that the standards drives out. There is a defined way of extending the catalog. So if we do have attributes that are unique to a broker or unique to an entity that we're doing business with, we can extend the catalog or the data dictionary in a way that's well defined, and they can consume it following those set of rules. So although it may be a new attribute, there's a defined way of adding that attribute and consuming that attribute. And another way we think it improves adaptability is around innovation, obviously. It can be innovation. I gave an example here is even though we have a common payload or structure of the data, how we deliver the data can be really diverse. Obviously, you have the RESO Web API, which drives out a well-defined protocol for how we distribute data. But we can also take that RESO payload and data stream it. So we work with some of our larger brokers that want the data in a different way. In that case, it's a push model where we're pushing the data to them and they're not pulling and asking us for changes. So even though we have a well-defined data standard, we also can use that to innovate new ways of delivering that payload to our end consumer that really bring value to them. One of the things I also wanted to cover was this concept of big data. I mentioned it earlier on that that's a lot of my background. And where we're looking at is addressing the four V's of big data that are kind of well known. And I added the plus one, which is really where the standards help out. Volume of data. As we know, there's more and more data being generated every day. And we went from gigabytes to terabytes to petabytes. As we have this, we need an infrastructure and a way to process that and consume that and store that amount of data. Data is coming in different formats all the time. You have well-structured data like a listing. You have unstructured data like videos or picture or audio file that needs to be processed. And as I said before, the velocity of that data is ever changing. And we're positioning more from the batch side of transitioning in this slide to the left, which is a real time. And real time is kind of where a lot of things are going. And the IDC believes that by 2025, over 30% of the data we capture will be driven out by real time access. So it's the ability for information to be consumed quickly, processed quickly, and given back to consumers in a way that they want it, but also at a speed they prefer it. Also, we have the veracity of data. It's the ability to give out trustworthy data. In some ways, it's better to have no data than data that's incorrect. If I have no data, I can make an assumption around that and make some decisions. If I have data that's incorrect, I make a decision based off incorrect data, I probably end up in a bad situation. So in some cases, it's better to have no data than incorrect data. And so as part of this big data model, we got to make sure we're pushing out trustworthy data to our consumers. And I think the key aspect, and this is really where the standards help out, is that distribution of data. Be able to distribute the data via a protocol preferred by the data consumer. So we can deliver the data in multiple ways, but the payload, the structure of the data is well defined based on the RESO standard. So if we pushed out that via an API, the RESO API, if we pushed out via data streaming on a report or any other way that the consumer may want it, having a common agreed upon structure, vocabulary, means I can deliver that and I can deliver in a way that's best for them, be it, as I said before, a simple API, or be it something like data streaming to get the data out in kind of a push model so they have access to it in a more real-time nature. One of the things I want to kind of lay out here for those at home, we're just curious about, I've simplified kind of some of Bright's architecture. And as I said before, or maybe I haven't said, we're pushing out to the AWS. And we're leveraging a lot of our data sharing, our data as a service based off of our data lake. And what we leverage from a cloud point of view is first the fact that there's a volume of data. As we said before, the first V in the big is our ability to store that volume data in an inexpensive media, be it Glacier or in our case S3, but be able to store that data out there. Be able to handle all the different formats. There again, S3 is an object store, so it could be an image, it could be a video, it could be a well-defined listing. All that is really just an object S3, so it doesn't matter what format the data comes in. I'm able to store it and maintain it there. We're able to have different service rates, so the ingestion, that black box at the top of the diagram, it could be a real-time feed, it could be a nightly batch, it could be something in between. But the velocity of the data is irrelevant to the ability to store the data and then store large sums of it. And then we move to the right, we start processing the data. Here again, I put a couple examples, and if you're an AWS people, you know Lambda EMR, but basically the ability to ensure the veracity of the data, the volume of the data, or the accuracy of the data that's theirs. But we keep the raw data, we also process that data. And then as we work from left to right, without going through all pieces of the simplified architecture, we're moving the data into high latency or low latency containers to be consumed out the door. If you look on the far right, by some well-defined APIs, or it could be as simple as dropping a report into an S3 bucket. The APIs, obviously, delivery will be based off of, once again, the data standards that RESO is defining. So as I'm plugging in new consumers of the data, they're always coming to a well-defined standard. And as I put more on the left side, we have more and more attributes we're storing. We can process them still and even extend the standard with new well-defined attributes that may be specific to a particular broker or a particular partner we're doing business with. So that's basically the latest. We've defined that at Bright. And this obviously, like I said before, is a simplified version to kind of show some of the capabilities we're looking at and that we're rolling out this year. And so as in summation, I appreciate you taking the time for this. Hopefully you've pulled out some new concepts or ideas of how we're leveraging data standards with our big data platforms to really drive out consumers and empower the consumers to make decisions. If you have any questions, I'll be online later to try to answer some of those, but I appreciate your time and everyone be safe.